All right, in this third video, we are going to be looking at matrices and averages, and we want you to be able to perform operations with matrices or a matrix, and also be able to find averages, including weighted averages. A matrix is an arrangement of numbers called elements in both rows and columns. The order or size of the matrix is always recorded as the number of rows by the number of columns, meaning rows always comes first, columns second. Here's an example of a matrix. Just like on a building, you got some of the big buildings like courthouses have columns. They are up and down or vertical. Columns are the vertical ones. So this one has 1 column, 2 columns, 3 columns, and 4 columns. Rows then are the ones going across. So this one would have rows 1 through 3 here on this one. So it has 3 rows, 4 columns. So when writing the size of this one or order, we would say this is a 3 by 4 matrix because there's 3 rows and 4 columns. Remember, rows always comes first. Okay, when looking at this, if there's different elements in different locations, and we want to put those, find that specific spot, then you just kind of use like a table and find that. So row 3, column 1, here's row 3. Okay, here's column 1. So the element in that location then is 3. Okay, if you're doing row 1, column 4, okay, here's row 1, column 4, the element in that location would be 2. Addition and subtraction of matrices is pretty easy. One thing you do have to have, though, is the same size matrix or matrices. So here, when we're adding these first 2 up, you can see they're both 2 by 2 matrices. We need that. Then you just add the same location. So when we're doing this one, 2 gets added with 6 to our resulting matrix. So this is going to be equal to 2 plus 6 would be 8, would be the what goes there. Similarly, these 2 would get added. 5 plus 3 is also going to give us 8. Then these 2 get added because they're same location. 1 plus 2 is 3. And finally, those last 2 numbers get added for 5. And so that's the resulting matrix. Subtraction works the same way. Again, you got to have similar size matrices. Here we have both 2 3 by 2 matrices, and so we can subtract them. And again, you just subtract the same location. Be a little bit careful with subtraction. Remember some of our subtraction stuff, especially with negatives and zeros. But adding the same spots, 9 minus 6 would give us 3. 2 minus 3 is going to end up being -1. Negative 3 minus 2. We're minusing a number, so we should get even a bigger negative. That's -5. 0 minus 4, -4. 5 minus 7 is -2. And then this last one, again, be careful with negatives here. 1 minus -3. Remember, minusing a negative is really like adding, so this ends up being +4. So just remember some of the subtraction stuff that you've done in previous years. Not a bad idea to maybe check with the calculator too, just to make sure you're getting the right numbers. Multiplying. Multiplying is just repeated addition. So if you want to multiply a matrix by 2, another way you can think of that is just adding 2 of them together. Well, if you added the same matrix by the same matrix here, 3 plus 3 being 6, and so on, you get this matrix right here. Well, you can see that if we were to just take this original matrix over here and times everything by 2, you would get those same 2 numbers. Like 2 times 3 is 6. 2 times -4 is -4. 2 times 4 is 8, and so on. So anytime you want to do matrices, scalar multiplication, just take that matrix, multiply by whatever number they have listed, and you can do that. So here, here's matrix A. Okay, they want us to find 3 times that matrix. So that means we just need to go through and times everything here by 3 to get the resulting matrix. So multiplying that, that's 6, 9, -2, 12, 16, 10. Now careful here, anything times 0 is still 0, so even when multiplying by 3 still is going to remain 0. -6, 3, 12, 21, and 27. So scalar multiplication of matrix, not very difficult either. What we're going to do now is just work on combining some of those. So if you got to do multiple operations, same thing here. So example 5 wants us to take 2 times matrix B and then add it to F. So multiplying matrix B by 2 is not difficult. Here's matrix B. So 2B would be 6, 30, and -16, just timesing everything by 2. Now we want to add that over here to F. We want to make sure if we're adding that they are the same size matrix, and they are. So now let's add those together. So adding together both this 2B1 and F will get a resulting matrix here. So 6 plus 12 would be 18. 30 plus -4 is 26, and -16 plus 16 would give us 0, and so that would be the answer there. Looking at another one here, the last one, number 6 with matrices, they want us to find -3e minus d. Why don't you pause the video and try this one and see if you can get it. All right, let's check out and see what you got. First thing you'd want to do is times this e1 here by -3, because we always do the multiplication first. So that would give us -3, -3, -3, -12, -12, 9, 9, and -6 and -6. Now we want to take this one and minus this d1 next to it and make sure we get everything. So I'm just going to copy that over here. And now we want to subtract all those. So the final solution matrix would look like this, same size again, because everything should end up being the same size. Subtracting those, you get -4, -15, -16, -7. Be careful with this middle one now. You're minusing a negative, so it's actually like adding would be 13. You got 9 minus 5 is going to give us 4. -3 minus 8 is -11. -13. And again, minus a negative with this last one is going to give us +3. And so that would be the resulting matrix there. Okay. Now, whoops, sorry, I screwed up on these. These should have been negative here when we were multiplying. So actually, I got 2. I got to change here. These ones should be with a -9. So -9 minus a -4 is still adding, but that'd be -5. And -9 minus 5 would be -14. So that would be the answer. All right. The other thing we're going to look at in this lesson is averages and weighted averages. So in this example, we have this table, or it's kind of like a matrix of values of data. And it says Isabel went up and down the street to find out how many parking spaces each house has. Below are her results. What's the average number of parking spaces? Okay, so when you find average of something, you add them up and divide by the total number. The problem is here, we don't really know what that is until we find it out. So one thing we need is, what is the total number of parking spaces here? Well, the total number of parking spaces would be from right here. Frequency means how many times did that occur. So one parking space occurred 15 times, two parking spaces occurred 27 times, and so on. So if we total these up, 15 plus 27 plus 8 plus 5 would give us the total number. So the total number here, adding all those up, would be 55 total times. Okay, but now we got to figure out, well, how many actually parking spaces were there? So This first one here would be if we had one parking space 15 times, that would be, multiplying that out, 15 spaces. Okay, but the next one is two parking spaces. So that occurred 27 times. So how many actual parking spaces? Well, if you have two parking spaces 27 times, 2 times 27 would be 54 actual spaces. And doing that with these other ones gives us 24 spaces here. And the last one would give us 20 parking spaces for the 4 parking space type. So now what we want to do is figure out, well, what is that total? Because that total is going to give us how many parking spaces total there were. So if we take all these and add them up and find that total, the total parking spaces was, adding all that up, going to be 113. So now we can find our average here by taking the 113 parking spaces divided by the 55 number of times, and that gives us how many parking lots. That gives us the total. So if you divide that out, you can find the average. So let's do that. 113 divided by 55. Looks like on average there's a little over 2, about 2.05 parking spaces. So each lot has slightly over 2 spots on average. Okay, next example says the final grade for a class is calculated by taking 75% of the average test score and adding 25% of the score on the final. If all the scores are out of 100, the student has a 76 test average. What score does the student need on the final to have a final grade of at least 80? This is what's called weighted average, because now we're dealing with percentages. There's a percentage here and a percentage here that together add up to our final grade of 100%. Of the grade. So what we have to do is take those and multiply them by what they got for the score on that category. So let's start with our 75% here. Remember, percentages we do need to enter as a decimal when putting them into a math problem. So 75% of the test score added to 25% of the final exam score is going to equal 100%, which would just be, changing that to a decimal would be 1 of, and this is going to be their grade. Okay, so now let's enter in what we know those are. So what did they get as a test average? Looks like 76. What did they get on the final exam? Well, that we don't know. They never, that's kind of what we need to find here, because they never told us what that's going to be. So we need to keep this as a variable. Let's just go with F so we remember it's the final exam. Equals 1 times their grade. And they did tell us the final grade. They want to get at least an 80 here. So 80 is what we want there. And at least, we'll talk about this more when we get into some inequalities, does mean equal to or actually greater than or equal to. So we could change that to a greater than or equal to. All right, let's solve this out now. So first thing we want to do, any simplification we can do, we do have some simplifying over here that we can multiply. So multiplying that out gives us 57. Okay, now just solving like we did on the last video. We can minus 57 from both sides. Now that's going to give us, it's going to give us a more simplified formula here. Okay, so now we know that they got to get 23 from their final exam score. Divide that by the 25%, and we can get that out. So now divide by 0.25, we can get it. And going on your calculator and do that means on the final exam they got to get a 92 or higher. So they got to get a 92 on that final exam in order to get the 80, a grade of at least an 80, probably meaning like a B or B minus or higher. So that would be the answer. Okay, let's try another one. Example 9. Final grade for Algebra 2 class is doing 70% of the average test score, 15% of your homework, and 15% of the final. Putting those together here. So if Ronald's current test score is 87% and the homework score is 96, what does he need on the final exam? All right, well, let's try to set up a similar equation here. We got 70% is test score, okay, and it looks like his test score is 87 here. 15% is homework, and looking at homework, that was a 96. Okay, and 15% final as well. Again, we don't know what that final exam score is, so let's put a variable f. And they want at least, meaning greater than or equal to a grade of 90. So adding all those up, you get your 100% of 90. All right, so now this is just another equation to solve out here. Why don't you pause the video and see if you can solve that out. All right, let's see how you did. Multiplying these, you get 0.609. Multiplying these ones, you get 0.144. We can't do anything with this one yet. Greater than 90. Sorry, 60.9. Now, add these ones up, and you get 75.3. Now doing some subtracting and dividing, we can get our answer here. So subtract those, and you get 14.7. Divide, and you realize the final, they got to get a 98 or higher. So what you should have came up with. All right, final one. John's college math grade is determined by taking the average of 5 tests. John got the following scores on his first 4 tests. What does he need to get on the 5th test? Well, this is not weighted average. This is just straight average. And remember, straight average, add them up, divide by how many. So if we add up the test scores, 87, 85, 93, and 88, that's not quite all the tests. There is still one missing test here we don't know. Let's just call it T for test. But we do know how many tests there are, 5. And actually, we do know what the average comes out to be. The average he wants to get is an 80. So we want to solve that out. So let's do what we can and solve. We can definitely add all the 4 tests up we know. So adding the 4 tests we know comes out to be 353. Plus, we still don't know that last test. Divided by 5 equals 80. Well, if this is an equation, equations are solving for the missing thing. Do the next best thing here. We want to solve for t. We got to get rid of this dividing, so let's times both sides by 5. So timesing by 5, there's 400 points available. So far, he's gotten 353. Last thing then, subtract. And you can find out what they need on that last test. So it looks like the last test got to get a 47 or higher, which shouldn't be hopefully too hard looking at the other test scores. Okay, try some of these now on your own.